Good morning. I, Vaishali Munjal, Assistant Professor in W Department at NGF College of Engineering and Technology, Palwan, welcomes you all in Power Electronics class. Today we are going to discuss a topic that name is Thyristor in the power electronics. Thyristor is nothing but a switching devices. Thyristor is made up of two things. One is transistor and another is Thyrotone tube. Transistors, as we all know, it is used for voltage step up and step down, and Thyrotone tube is nothing, it's a kind of a CRT tube. So it's a combination of both. Before this, we were using PN junction diode, MOSFET diode for the switching purpose. So now what's the difference in the thyristors and what so make this thyristor unique? We will discuss in this lecture. It's a basic symbol of a thyristor. We can see it is like a conventional PN junction diode, but the difference is that gate terminal is extra in this. Gate terminal makes that thyristor unique. Gate terminal is used for controlling input signals. And a thyristor is a unidirectional device, which means current flow in one direction, example anode to cathode. Next we can say it is a basic diagram of a thyristors. We can see here four layers are there, PN, and three terminals are there, anode, cathode and gate, and they are making three junctions here. In the next slide I have named that three junctions J1, J2 and J3. We will see now its basic operation, how that thyristor works and how or what that thyristors make so unique. So here we can say there are three terminals, anode, cathode and gate, and three junctions J1, J2 and J3. We will produce or we will apply the biasing in this, and we will get three modes here: reverse blocking mode, forward blocking mode and forward conduction mode. So we will use first reverse biasing. For reverse biasing, everyone knows we connect P side to negative and N side to positive. This is the reverse biasing. By this, the junction J1 will be in the reverse bias and junction J3 will also be in the reverse bias. But J2 junction will be in the forward bias, which is making a hurdle for current flow in the reverse biasing. That is known as, that condition is known as reverse blocking mode. Next, if we do the biasing in the forward bias, we will connect P to the positive side and N to the negative side. This is known as forward biasing. By applying this, the junction J1 will be in the forward bias and junction J3 will also be in the forward bias and junction J2 will be in the reverse bias. So reverse bias is like a hurdle here. We can say we increase voltage here, but still here is a hurdle. This condition is known as forward blocking mode. Or while applying the more voltage from the outside, the junction J2, which was in the reverse bias, now that depletion layer here will reduce and suddenly it is break or current start increasing or flowing randomly. That condition will become our forward conducting mode. In the next slide, we see how the current flow, or we can say we see the VI characteristics of a thyristors. Still, the gate current is still 0. I'll tell you when this gate current will work for a thyristor, or we can say when this gate terminal will be in use. So first we have studied reverse blockage. This line is showing the reverse blockage mode, where the current increase slowly and a point comes where the avalanche breakdown occur, where current start increasing rapidly and voltage remains constant. This is the first mode. And the second mode that we have discussed is forward blocking mode. So this line, as you can see, up to VBO, this line is showing the minimum current is flowing. This is known as forward blocking mode. So now where when the depletion layer vanishes in the junction J2, the voltage will be go minimum. That curve is showing that voltage go minimum and current will start increasing rapidly in the forward conduction mode. That line is showing that forward conduction mode. So when the use of this gate terminal, we can see here that we have to apply more and more voltage for getting this forward conduction mode from outside. So this is a kind of a loss for us. So gate voltage or gate terminal is used to reduce that loss when applying gate voltage. So we will get this conduction mode here very soon. So that makes thyristors unique. Thank you so much.